Guys, so this is 3.5 exponential and logarithmic models. This week there is a big focus on story problems. So let's try some of these story problems together. Here we go. Newton's law of cooling. This is probably something you have done in your science class. So the temperature T of an object, so the capital T stands for temperature and the lower t stands for time. So we're looking at temperature in terms of time. And that is the formula. T sub S is going to stand for the surrounding room temperature. T sub O is the initial temperature of the object. So looking at example 1, it says that we have a 350-degree potato. It's left out in a 70-degree room for 12 minutes, and its temperature dropped to 250. So what we're going to do is use this formula to figure out what K is. So K is that constant where the temperature is dropping at a certain rate. So we're going to figure out what K is. And then once we find K, we can answer the end question, which is how many more minutes will it take to reach 120 degrees? So this is a two-part problem. So we're going to start with the first part, and we're going to plug in what we know. So temperature in terms of time is 250 is what that temperature dropped to over time. So that's your temperature in terms of time. T sub S is your room temperature, which was 70, plus T sub O is your oven. When it comes out of the oven, it was 350. Subtract your surrounding room temperature, which is 70 again, and then times base E, and then it's raised to the negative K, and then T is 12 minutes. It took us 12 minutes to drop to 250. So the math isn't super hard on this. It's just plug everything in. And what is our goal? Our goal is to figure out what K is so that I can answer the question in the blue. So you would start just by simplifying this. So you could do the 70 that's being added, you could subtract it over to this side. So you have 250 subtract 70, which is 180. So this is 180 equals, and then 350 subtract 70 is 280. So 280 E raised to the negative 12K. I'll just switch the order. Now, the goal is to get the base to the exponent all by itself. So that's our goal. So we are going to divide by 280. Those cancel. The zeros are going to cancel. Now I have 18 over 28, which is 9 over 14. So I've got 9 over 14 is equal to E raised to the negative 12K. Now, in order to get this K down in front, we're going to use the property of logarithms, and or the power property. So I'm going to multiply both sides by ln, and the reason why I picked ln is because ln E is going to end up equaling 1, and I can explain why here. In the Cornell, if you have ln E equals something, we know that the base for ln is always E. So it'd be E to the question mark is equal to E. Well, what's that question mark? The question mark is 1. So what does ln E equal? ln E is always equal to 1. I recommend memorizing that because you tend to see it quite often. So ln E is equal to 1. So I took the ln of both sides. Now what I'm going to do is use this power property, which says I can take this exponent and bring it down in front as multiplication. All right. So I wish I didn't write so big on here, but I have ln 9 over 14 is equal to negative 12k ln e. And then I want you to note the ln e is 1. So you can replace that with a 1. And 1 times anything is itself. So that's just negative 12k. You're solving for k, so you're going to divide both sides by negative 12. Okay? That was ironic. KK. All right, so then on the calculator, you're going to do fraction bar, green alpha F1. Then you're going to do ln, which is to the left of 4, over ln 9 over 14, and then divide that whole thing by 12. Oh, sorry, we don't want that. All right, so do that, and you're going to get k is equal to 0.037. Now, I would store this. So store that value so that you can use the full number and not just the stored number. All right, so now what we're going to do is we're going to come up to this same equation, but this time we're going to find out how many more minutes it takes to reach 120. So this time the temperature in terms of time drops to 120 degrees. The room temperature is 70 plus 350 is how much the potato when it comes out of the oven is. Subtract the room temperature 70 times E raised to the opposite of KT. Now, if you want, you could put in for K what K equals, which is 0.037. However, when I use my calculator, I will use the full number, not the rounded. Okay, so let's figure out what T is. The process is going to be the exact same as before. Subtract 70. So 120 subtract 70 is 50. 50 is equal to 350 subtract 70 is 280. E raised to the negative 0.037 T. Again, we want to isolate. So I want to don't scribble that out. I want to isolate this part of the equation. So this is 280 times E. How you get rid of that is you divide by 280. So we would divide both sides by 280. This gives us 5 over 28. So 5 over 28 is equal to E to the negative 0.037T. Now I want this T to be multiplied down in front, so I'm going to take the ln of both sides of the equation. Now that's going to allow me to use the power property, which means I can take the power and bring it directly in front of the ln as multiplication. So now I have ln 5 over 28 equals negative 0.37037 T ln E. And then ln E is 1, so that's gone. And then you're just going to divide by K. Now, if I were doing this problem, I probably would have not put in the 0.037. I probably would have just done K there because in my calculator, I have K stored. And so in my calculator, I would just divide this thing by K because you want to divide it by this full number, not just the decimal part. All right, or the rounded part. So T equals, if you did that right, it's going to be 46.790. So T is equal to 46.790 minutes. All right, so that's the answer to the question in the blue. Let's go ahead. It takes about blank minutes for the potato to cool. So if we're doing the about, we would just say about 47 minutes. And this is how many minutes longer. So if you take the 47 and you subtract the 12, it's going to be 35 minutes longer. And that was a good 10-minute problem. And I almost wonder if we shouldn't do that one in class. All right, next problem. So this is a compound interest problem. And I would recommend, I mean, I think this formula is a good one to have memorized. This year, because we're using open notes, of course, you would have access to it. In typical school years, I would have you have that formula memorized, so maybe you want to memorize it. A stands for the balance. P is how much you're investing or borrowing. R is your percent changed to a decimal, so your rate. N is the number of times you compound, and T is your time in years. So this is the same formula that we've been dealing with. The only difference is we're going to have to use logarithms, because this time the question is, how long will it take? And so we're going to be looking for this T up here in the variable. On the other problems, we were looking for A, so it was a little bit easier. So you're going to do the same thing that you did before. You're going to use the formula and plug in what you know. So how long will it take an investment of $2,000? So keep in mind that the investment is always your principal, or how much you borrow is always your principal. So this 2,000 is going to go here. And then it's going to be 1 plus the rate is there, so it's 0.06 over n. N is how often it's compounded. Semi-annually is twice a year, so this would be 2. Quarterly would be 4. Just annually would be 1. And then you're going to raise that to the n again, which is 2. And T is what we're looking for in the problem. It says to reach an amount of 5,000. So this total amount is always this number over here on that side. Actually, I think I'll go back to black. So 5,000. All right, so that's your equation that you're going to be solving. You're going to start like order of operations with the parentheses. So you're going to have 5,000 is equal to 2,000. And then you have 1 plus 0.06 divided by 2. And that's 1.03. So this would be multiplied by 1.03. And then that is going to be raised to the 2 and then times T. Now, same thing as before. Story problems, you want to isolate the base. So we're trying to isolate this base. So the first thing I want to do is get rid of the 2,000. So I'm going to take the 2,000 and I'm going to divide it over to this other side. So now this just gives me 5 over 2. You can cancel all these zeros, is equal to 1.03 2 to the T power. So now we're going to do that where we take the log or the natural log of both sides. And you can pick log or you can pick natural log. It doesn't matter. From there, the 2T power property can come in front as multiplication. So you have log 5 over 2 is equal to 2T log of 1.03. So now all we have to do is get T by itself by undoing multiply by dividing. So I'm going to divide both sides by 2 log 1.03, and I'll divide that side by 2 log 1.03. And then you're going to see that the 2's are going to cancel and the log 1.03's are going to cancel. You've got T by itself. This is kind of a messy calculator problem. I do recommend using the fraction bar, green alpha F2 to help you. No, green alpha F1 is the fraction bar to help you out. And then when you throw that all into the calculator, which you really should to make sure you're using the calculator correctly, we're going to get T is equal to 15.499 years. So approximately 15 years. So it will take about 15 years. All right, so that is the answer to that one. The reason why we're going to use a different formula is because when you see compound continuously, then this is the formula you use. I call it the PERT formula. It sounds like a shampoo or something, but it's P times E raised to the RT. So that's the compounded continuous formula. We're going to plug in everything that we know. So we have how long will it take for an investment? So an investment is always your principal. Oh, I don't want red. Control Z. Let's do purple. All right, so P is going to be 2,000. So I'll put in 2,000 times E, and then raised to the R. The rate is 6%, so we change that to a decimal. And then times T, and T is the time. I don't know what the time is. And so the question is asking, how long will it take? So that's what I'm looking for is T. The total amount that the money reaches is going to be $5,000. Now, because this is similar to the same problem, I just think it should take me slightly, I should get my money slightly quicker than the other one, because compounded continuously means you're always compounding. And we remember we talked about how always compounding is going to approach that magical number of E. So we want to do the same thing that we did before, and that is you want to isolate your base E. All right, so we're going to start by dividing both sides by 2,000. So I can isolate E. I love it when you can just cancel out all those zeros through division. So now I have 5 over 2 is equal to E raised to the 0.06t. Now I'm going to use my property where I can take this and bring it in front if it's a logarithm. So I take the natural logarithm of both sides. You want to pick ln to go with E. Then ln E is going to end up giving me 1. So this is ln 5 over 2 equals, bring this in front, 0.06t times ln E. ln E is 1, so it's gone, because 1 times anything is itself. Divide by the 0.06. Remember, ln is to the left of 4, and this is one big calculator problem, and you're going to get t is equal to, we're still at 15 years, but it's 15.272 years. So, I kind of don't like that they both come out as 15. I would almost rather that we round these. So 15.272 is a little bit quicker if we go back to the last problem than 15.499. The other thing would be if we wanted to call this 15.5 years, and then this one would be 15. So annual percentage yield is really useful for comparisons. So it's used a lot in the housing market, and it's because it's a percent, and it's easy to compare percents. So it'll be the rate compounded annually, which means your time is going to be equal to 1. Here is the APY formula. So let's try an example. The amount of $2,400 is invested for 8 years at 5% compounded quarterly. What is the APY? So for this one, you would do the APY is equal to 1 plus, you're looking at your rate, which is 0.05. It's compounded quarterly, so you would divide by 4, raise to the 4th, and then subtract 1. Basically, you're just going to throw that all into your calculator, and it's going to come out as 0.051. And then APY is listed as a percent, so we'll change this to a percent, and your percent would be 5.1%. So as an annual percentage yield, you would be getting 5.1% on your investment. Okay, on your own, if you'll do the U try and then answer the reflection question. If I didn't explain annual percentage yield, APY, very well, this would be a good topic to Google, especially if you're interested in business. So why is using the annual percentage yield a more fair way to compare investments? Hey, have a great day.